Okay, that's a good point. But let's bring this back up. Recall, let's get the table out. Delta H naught, delta S naught, and delta G less than 0, which is the process for spontaneity. So you're right, I didn't completely answer that. At what temperature is it going to be spontaneous? Now we had a positive enthalpy, right? And we had a positive entropy. And so delta G is going to be less than 0. Since this is positive, it's only going to be less than 0. Temperature has to be greater than delta H naught over delta S naught. That's absolutely true. And so that would be, so therefore, T has to be greater than 300 K. But the inflection is going to occur at 300 K. So I sort of answered a more restrictive answer.
So you would plot the inequality? You would mark this down if we used
I would, if you used equal, I would be happy, but if you recognize that it had to be greater than that, I'd be even more happy.
Extra credit?
You know, just extra insight. Okay? But you're absolutely right. Feel free to take it as far as you can. And I like that. So you get the most out of the answer. Yeah, that would be. But this would, remember, we constructed such a table for different conditions. If enthalpy is positive and entropy is negative, at what temperature is it going to be spontaneous? It's never spontaneous. But conversely, if the enthalpy is negative and the entropy is positive, what temperatures is it going to be spontaneous? For all temperatures. And then the last is, if I have an exothermic process with negative enthalpy and negative entropy change, which is called exentropic, then it's going to be, both of these are negative, it's going to be spontaneous for what condition? Temperatures less than the threshold. So we just sort of found that threshold temperature where the inflection occurs for this process. Okay? And